Hi, hello, welcome back to my YouTube channel. So today I am going to tell about characteristic function of binomial distribution. Okay, so characteristic function is also denoted with CF. So its symbol is phi x of t. Okay, so phi x of t equals to expectation of e power itx. Okay, so it is of the form, so that means e power x, it is of the form e power x. So its formula is summation x into p of x. We can write like this. So we are writing this one as this form, so that equals to summation x into x in the sense what here, e power itx into p of x. Okay, so what we have to write here in the sense limits of binomial distribution is x equals to 0 to n. Okay, so that equals to here p of x formula, binomial distribution p of x formula is ncx p power x into q power n minus x. Okay, so summation x equals to 0 to n e power itx into p of x in the sense ncx p power x into q power n minus x. Okay, so now we'll write this term in order. Okay, so summation x equals to 0 to n. First we'll write ncx. Next, here if you observe, e power we are having x and p also we are having x powers. So we'll write this both into single term. Okay, so p into e power it whole power x into q power n minus x. Okay, so now we are going to remove this summation. That equals to nc0 p into e power it whole power 0 into q power n minus 0 plus nc1 p into e power it whole power 1 into q power n minus 1 plus nc2 p into e power it whole square into q power n minus 2 plus and so on plus ncn p into e power it whole power n q power n minus n. Okay, so this one will be of the form x plus y whole to the power of n. Okay, so this expansion will be same like this expansion. We will see once. Okay, so this expansion is ncx. Okay, so x to the power of 0 and y power n plus one here, nc2 x power 1 into y power n minus 1 plus nc3 x square into y power n minus 2 plus and so on plus ncn x to the power of n into y to the power of n minus n, nothing but 0. Okay, so if you compare these two terms, it will be same. Okay, this term and this term, if you compare, it will be same. But in place of x, we are having p into e power it. In place of y, we are having q. Okay, so now we have to write this whole term in this format. Okay, so therefore, pi x of t equals to, so x in the sense what? P into e power it plus y in the sense what? Y in the sense q whole power n. Okay, so therefore pi x of t equals to q plus p into e power it whole power n is the formula for pi x of t. Okay, so now what we have to do is, now we have to calculate mean. Okay, so mean of binomial distribution using characteristic function. Okay, so now what we have to do is, we have to calculate mean of binomial distribution using characteristic function. Okay, so here mean is denoted with mu1 dash, that equals to, so here we have to differentiate with respect to t. the characteristic function. Okay, so for that we have to write mu1 dash equals to minus I. We have to include. Why? Because in characteristic function we are having I variable. So in order to eliminate that I variable, here we have to include I variable. Okay, so minus I d by dt of phi x of t, where t equals to 0. Okay, so minus I d by dt of phi x of t in the sense what? Q plus p into e power it whole power n. Okay, we have to write this formula where t equals to 0. Now we have to differentiate this term with respect to t. So that equals to minus I. This is in the form of x power n. So n into q plus p into e power it whole power n minus 1 into, again this term, p into e power it, again t we have to do. So t coefficient is I. Okay, where t equals to 0. Now we have to substitute t equals to 0 wherever we are having t. So that equals to minus I, here also I. So minus I square n into q plus p into e power I into 0 whole power n minus 1 p into e power I into 0. Okay, so that equals to minus I square n into q plus p. E power 0 will get, e power 0 is nothing but 1. So q plus p whole power n minus 1. P into e power 0 will get, e power 0 is nothing but 1. Okay, so that equals to minus I square n into q plus p is nothing but 1. Okay, 1 to the power of n minus 1 into p. So that equals to, so here how many times we do n? N minus 1 we'll get 1 only answer here. Okay, so how many times we square it also, it will be 1. So minus I square into np. Okay, so we know that I square value is minus 1. Okay, now we'll substitute here minus of minus 1 into np. So therefore mu1 dash equals to np. Okay, so now what we have to do is we have to calculate variance. Okay, so variance of binomial distribution using characteristic function. Okay, so variance is denoted with mu2. Mu2 equals to mu2 dash minus mu1 dash whole square. So we already calculated mu1 dash. Now we are going to calculate mu2 dash. Okay, so mu2 dash equals to, now we have to keep here I square. So if you observe here, this is minus 1 we kept. Why? Because this is a odd non-central moment, no? So odd number, 1 is odd number. So here 2 is even number. For even number we should not add minus. For odd number we have to add minus. So that's why we have kept here minus and we did not keep here minus. So we are just writing I square. Why? Because here 2 is there, no? So I square d square by dt square into phi x of t, where t equals to 0. Okay, so now what we have to do is I square into, we have to split this one, d by dt of, again d by dt of phi x of t, where t equals to 0. So that equals to I square into d by dt of, so d by dt of phi x of t we have to write d by dt of phi x of t in the sense what? Q plus p into e power it whole power n. Okay, where t equals to 0. So first we have to differentiate this term. So I square into d by dt of x power n into q plus p into e power it whole power n minus 1 into p into e power it into I, where t equals to 0. So that equals to, so here I square, here I. Or else we'll keep here itself. What is it? Or else we'll bring. So I square here. Here I we are going to bring outside. So I cube. So here n, p also we are going to bring outside. So np d by dt. Why? Because these terms are not having t variable. That's why we took this term outside. So into q plus p into e power it whole power n minus 1 into p into e power it, where t equals to 0. Now we have to differentiate this term. So this is u and this is v. So p we already took outside. So here only e power it is left. So this is u, this is v. So the differentiation of uv is uv equals to u dash v plus uv dash. Okay. So I cube into np into u dash we are doing. So x power n, it is of the form x power n. So n minus 1 into q plus p into e power it whole power n minus 1 minus 1. Okay. Into p into e power it into I. Okay. Into u, v dash we did, here u dash we did. Now we have to write v as it is, e power it, plus now we have to write u as it is. So q plus p into e power it whole power n minus 1, and v dash we have to do e power x is e power x, e power it. So but we are having here t quotient as I. So that's why we are making it into I. Okay, where t equals to 0. Now we have to substitute t equals to 0. I cube into np into n minus 1 into q plus p into e power I into 0 whole power n minus 2 p into e power I into 0 into I e power I into 0 plus q plus p into e power I into 0 whole power n minus 1 into e power I into 0 into I. Okay. So now here I cube into np into here n minus 1. Here see q plus p e power 0 will get. E power 0 in the sense what? 1. Q plus p in the sense 1. So 1 to the power of n minus 2 will get in place of this. Okay. So p into e power 0. E power 0 is 1. Okay. So p into 1 is nothing but p, plus here again I is there, no, sorry, I e power 0 is 1. So here I also will be. Okay. Plus q plus p into e power 0 will get. So e power 0 in the sense 1, q plus p whole power n minus 1 in the sense q plus p in the sense what? 1. So 1 to the power of n minus 1 into e power 0 is nothing but 1. 1 into I is I. Okay. So that equals to I cube np into n minus 1 into here 1 only will get into IP, plus here I only will get. Okay, here 1 will get, here I. So in these both terms we'll make I as common. So I power 4 into np into n minus 1 into p plus 1. Why? Because here we took I as a common. Okay, I cube is there, no? Into I is I power 4. Okay. Here this one we can write I square into I square. Okay, into np into np minus p. Here n into p is np, minus 1 into p is minus p plus 1. Okay, so that equals to I square in the sense what? Minus 1. So minus 1 into minus 1 into np into np minus p plus 1. So that equals to np into np. How much we'll get? Or else here, okay, we'll write it. N square p square minus np square plus np. So this is what? Mu2 dash value. Okay, mu2 dash value. So now we have to find out variance. So mu2 equals to mu2 dash minus mu1 dash whole square. So mu2 dash in the sense n square p square minus np square plus np minus mu1 dash in the sense what we got? Np. So np whole square. So that equals to n square p square minus np square plus np minus n square p square. These both terms will get cancelled. That equals to minus np square plus np. That equals to, here we will take common as np. np into, here 1 will be, here only p will be remaining. So 1 minus p is nothing but q. So therefore we'll get npq. Okay, so therefore mu2 equals to npq, which is variance. Okay, so like this you have to calculate. Okay, so I think everybody understood. So thanks for watching my video. If you are newly watching my video, please subscribe my channel and share with your friends and also give a like. Okay. Thank you for watching. Have a nice day. Bye. Take care.